Good morning, everybody. Today I will be talking about velocity and acceleration. Um, those are two quantities, vectorial quantities, so those are vectors that we experience, for which we experience every day some effect. I will go from definition, example, and some exercise at the end. Okay, so what is velocity? So first of all, you know that we can describe the position of an object with a vector, and if this object is moving in time, the position of that vector will change as well. Now it's easy to have a frame of reference for which we can uh, derive our position vectors and locate the body, center of mass of the body, and therefore having the exact position of that in a graph. And then we can define the difference of the position over time of that of the object, and this will give us another vector which is called velocity, instant velocity. Also, we need to remember that this change in position can happen in magnitude or in direction or both. For example, if you think about a circular motion, the earth spinning around its axis, the rate at which it's spinning, it doesn't change during the day because every day is after all 24 hours anyway, but the direction is changing um, quite clearly because actually um, you revolve around the axis. So yes, so these are basically the main definitions of velocity. Okay, then we move to acceleration. Very similarly, once you define the velocity, you do you have the same you can do the same that we did for the position to get the velocity and to go from velocity and to get the acceleration. Basically, um, we define the velocity at 2 points in time, and we make the difference of that. And the difference over time of a velocity of an object is basically the acceleration. We experience acceleration every day in life as well. For example, if you think about when you are in a bus moving from A to B, and the bus starts or stops moving, you experience in your body a push forward or backward, depending if it's starting or stopping. And this is an acceleration because there's a change of velocity of your body because of an external event. We will get back to that in the dynamic. But okay, so and as well, the acceleration can be in magnitude and direction or both, and as we will see in more details in other lectures. Um, one one key important aspect is that if we have access, or we can draw the graph of the position over time or the velocity over time um, with a pen, for example, in a chart, we can easily see that the velocity is respect to the position a vector which is tangent to the curve, or the acceleration is a vector that is tangent to the velocity curve. And this can be seen with a simple graph, as you can see here. In a small, we have a black curve which is the position over time, and we have two vectors, the yellow and the blue, which are very close to each other. And we can see that the difference of that vectors is a red vector that is pointing tangentially to the curve, and the tangent is more clear. The smaller is the interval of time. So basically, we are saying that the velocity is the difference of x over dt when dt is very small. And this is a very important concept because we are leaning towards the concept of derivative. Now, another important aspect is that at the moment we have shown instantaneous velocity and instantaneous acceleration because we identified a single point in time for which we calculate the difference in distance over that period of time. But of course, you can measure that quantity many times, or if you can't, you can always sample the position at different location during a journey, for example, depending on your measurement. And the fact that there are external variation or measurement errors allows us to introduce a very important concept, which is the average velocity or average acceleration, which is the arithmetic average of the quantity that you collect and quantity that you collect. So the sum divided by n, where n is the number of measurements that you've done or different collections of velocity or acceleration. And usually this will give a more precise value of the quantity that you want to measure, because it will exactly average out the plus or minus effect that are due to measurement errors or external quantities that varies in time. Okay, having said that, we can see a graph of velocity, which is green, and an acceleration. As you can see, where the velocity is changing with a line, the first few points, the acceleration is constant, is flat. Where the velocity is constant, flat, the acceleration is zero because it's not changing, as and so on and so forth. So when it's linearly increasing, we can see a constant acceleration. When the acceleration is not constant but is linear, for example, there is a quadratic acceleration in velocity, as we can see in the graph. So this is just a simple way to represent velocity and acceleration related one to another. Okay, I hope you understand. There will be some exercise in the next slides, and see you soon. Best.